All right, so what I'm going to try and do now is I'm going to try and explain a very important and very kind of simple but seemingly confusing theorem, mathematical theorem to you, okay? It's called the intermediate value theorem. And I understand that two of those three words are big words that are sort of you don't really want to wrap your mind around them. But honestly speaking, the intermediate value theorem, which is sometimes referred to as the IVT, is actually extremely simple. In fact, by the time you understand the intermediate value theorem, you're going to say something like this. Well, why do they have to make such a simple concept so complicated? I agree with you to a certain extent. Here's the thing. The intermediate value theorem, in fact, any theorem in mathematics, has to be stated in such a way that it is airtight, that there are no circumstances in which somebody can say, yeah, but what about the situation where blah, blah, blah? It has to be able to answer all of those annoying objections. These theorems have to be able to do that. And so, like I said, the IVT is extremely simple, but it's stated in sort of a logical and complicated way such that it uses phrases like such that. And so what I'm going to try and do is I'm going to give you little pieces that help you understand the intermediate value theorem, so that if you understand the little tiny pieces, we can put the little tiny pieces together, and then you can have a basic understanding of the intermediate value theorem. By the way, intermediate means in between, value means a number, and theorem just means that it's like a law of math, okay? So it's a law pertaining to numbers that are in between other numbers. That's really all it is, okay? The intermediate value theorem. All right, so here's the idea here. I just want to expose your mind to a bunch of crazy looking symbols, okay? Well, they're not that crazy looking. They're just letters, right? But every time we put letters in math, people get upset. They're like, hey, this is math. It's supposed to be numbers. You know, it was bad enough I had to learn letters in English class. Why are you throwing letters into math? Let's just get to it, okay? And I'm going to help you to understand the letters in math. Okay, so let's say that we have some function. Okay, we're going to say that f of x, f is a function of x is a variable, right? X can take on all different kinds of numbers, an infinite number of different values, okay? And f of x is a quadratic, x squared minus 5x plus 1. And here's what we're going to do is we are going to specifically say that this function, we're only looking at this function on a closed interval, okay? On the interval from A to B. You're like, all right, Mr. Ryan, that's not an interval of numbers, that's letters. Yes, here's the thing. I understand they're letters, but that's because in order to make a generalized statement that applies to any kind or any value of numbers, we have to use letters. That's exactly why we're using x as a variable. Now, here's the interesting thing. Even though A and B can represent almost any numbers, in this case, A and B are supposed to be representing two very specific numbers. So, if you were to pick a number for A and a number for B, then this function would be represented on that specific interval. And so what I'll be doing is I'll be giving you a value for A and a value for B, okay? So once we have this information, so we have a function and we know that this function is a function on a closed interval, that's what the brackets are for, closed interval, including A and B and all the numbers that are between A and B. A is always a smaller number, B is always a larger number, okay? So then the question is this. Here's what we want to try and figure out. This is all we're doing in this particular video as we work up to the intermediate value theorem. We just want to answer a simple question. Is f of c equal to k? Is that a number between f of A and f of B. That's all we want to know. Now, you might say, you got a whole bunch of letters in there again, Mr. Ryan, and I'm saying, yes, I understand that. But we already know that A and B are numbers, right? So if A, let's say down here, so here's the example we're going to do. In almost every case, pretty much every case, I have to give you a number for A and a number for B. So in this particular case, A is 2 and B is 5. So we would reread this and we would say, let f of x, this function, be a function on the interval from 2 to 5. Okay, because we're saying that A is 2 and B is 5. So then we're going to ask the question, is f of c equals k a number between f of 2 and f of 5? Okay, so in order to determine that, we would need to know what f of 2 is, and we would need to know what f of 5 is. Well, up here we also have this c and this k, right? Well, k is just simply an output, right? Okay, you know, whenever we plug a number, c, in this case c is representing a number, whenever we plug a number into a function, we know that we get an output number, if there is an output number. And what all this little statement, this little equation is saying is that k is a number. It is a numerical output of this function when you plug in the letter c. But not the letter c. C is actually representing a value. We just don't know what that value is. So if there was a value, a number that we could plug into this function, the answer would be whatever the number k is. And down here you can see that we're for this particular problem, we're going to say that k is equal to 0. So what we could do is this, is we could say, let f of x be this function on the interval from 2 to 5. And then we're going to ask the question, is f of c equals, instead of k, 0? Is that a number between f of 2 and f of 5? And so now, in order to answer that question, we would need to find out, well, what is f of 2 and what is f of 5? Well, how can we answer that question? Well, we can plug 2 into f of x. Here's f of x. If we put a 2 here, right, and a 2 here, we would find out what f of 2 is. So let's go ahead and do that. Let's put 2 squared. So f of 2 would be 2 squared minus 5 times 2 plus 1. Right? Well, 2 squared, that's 4, minus 5 times 2, that's 10, plus 1. Well, 4 minus 10 is negative 6, plus 1 is negative 5, and therefore we're going to put down here that f of 2 is equal to negative 5, right? Now let's do the exact same thing for f of 5. Let's plug 5 in here, and we would do 5 squared minus 5 times 5, which, by the way, is 5 squared. So 5 squared minus 5 times 5, that's 0, because these are both mean 5 times 5, plus 1. So 25 minus 25 is 0, plus 1, that's 1. So we know that f of 5 is 1. And so now the question is 0 a number between negative 5 and 1? Well, if you were asked that in like 2nd grade, you could answer that question. Is 0, but well, maybe not. I don't think you learn negative numbers until you get to maybe 4th or 5th grade, but still. Is 0 a number that is between negative 5 and 1? Well, if we go to a number line, we know that negative 5 is over here. We know that 1 is over here. Well, where's 0? Well, 0 is right about here. So yes, 0 is between negative 5 and 1. And so that's basically the only question that we're asking here is 0 between negative 5 and 1? And by answering that, so the answer to this is yes. Okay? But the way we had to answer that is we had to identify the value of k, we had to identify the value of f of a, which is f of 2, which is negative 5, and we had to identify the value of f of 5, or f of b, which is f of 5, which is 1, okay? So we had to identify the value of k, the value of f of a, and the value of f of b. And once we were able to identify those three values, we were able to answer yes, 0 is between those two numbers. And that's all I want you to do in this particular video, is get used to identifying f of a, f of b, k, and then determining if k is between these two numbers, okay? So let's do another example very similar to this. All right, so let's look at this one. This time f of x is a piecewise function that transitions at a value of 2. So at all values of x less than 2, less than or equal to 2, we're going to use this top piece, x cubed plus 7. And at all values larger than 2, we're going to use this piece, x squared minus 11. And we're saying that this function is relevant on the interval, the closed interval from a to b, okay? Now, we can look down here and we can see that a and b are the values 1 and 3. So this function is starting at 1 and ending at 3, okay? And then it says, is f of c equals k a number between f of a and f of b? Well, what is k in this case? K is 5, okay? So we're being told this is the additional information, right? So k is 5, and we want to know if the output value 5 is in between the output value of the function at a and the output value of the function at b. And so the way that we're going to figure this out is we're going to need to plug a into the function and b into the function. So we need to identify f of a. F of a, since a is 1, f of a is the same thing as f of 1. And to find f of 1, we're going to have to plug 1 into the function. Now, 1 is less than 2, so we got to plug it into this top part. 1 cubed is 1 plus 7 is 8. So f of 1 is 8. Done. Now we're going to do f of b, and that's equal to f of 3, right? Because in this particular problem, the end of the interval is 3, f of 3. Now 3 is larger than 2, and so we got to plug it into this piece. Well, 3 squared, 3 times 3 is 9. 9 minus 11 is negative 2. Okay? And so we have f of a, which is f of 1, which is 8. And we have f of b, which is f of 3, which is negative 2. And k was given to us, that's 5. And so what this is asking is 5 a number between 8 and negative 2? And the answer is yes. Now you might be thinking, well, wait, shouldn't the smaller number be f of a and the larger number be f of b? A is a smaller number and b is a larger number. The input values have to be smaller and larger, but that doesn't mean their output values have to be larger, okay? Their output values can be equal. They can be one, the first one is higher and the second one's smaller, or the first one's smaller and the second one's higher. As far as output values, there's no restriction. There's no absolute need or guarantee that f of a is always going to be smaller than f of b, even though a is always smaller than b. For example, what if I gave you x squared as a function, right? Just f of x is equal to x squared. Let's say we were plugging in negative 7 up to negative 5, right? Well, negative 7 times negative 7, if we plug negative 7 in, its output, f of negative 7, in this case, is 49. And if we were to plug in negative 5 squared is 25. Well, look, this just means that there is a negative slope on this function. It's going from 49 down to 25 as the x increases from negative 7 up to negative 5, okay? So this is okay. So we do not care whether it's going from smaller to larger or larger to smaller. All we care is the value k, but is this number k, which is 5 in this case, is that a number that's between 8 and negative 2? And it is. And so we would say yes, 5 is between 8 and negative 2. Okay? All right, let's do another example. All right, let's try this one. It says, let f of x equal 2 minus x squared plus x on the interval from a to b. In this case, a and b are 3 and 7. Is f of c equals k? Is this output? This is also an output. This is just simply saying the output of the input c. If if I plug c into the function, will the output be this number, and will that number be between the output if I were to plug A in, which is 3, and the output if I were to plug B in, which is 7, okay? So all this is saying is f of c equals k, in this case k is -1, so is -1 a number between f of a, well f of a is f of 3, so we're going to say f of a is equal to f of 3, and to get f of 3 we are going to plug 3 into f of x, so we're going to put a 3 up here. So we'd have 2 minus 3 squared. 3 squared is 9 plus 3, right? Well, 2 minus 9, that's -7. -7 plus 3, that's -4. Okay, -4. Very good. And now, between f of a, which in this case is -4, and f of b. Well, what's f of b? Well, f of b is going to be f of 7. 7. All right, so let's plug 7 in. 2 minus 7 squared is 49 plus 7. Well, 2 minus 49, that's -47. -47 plus 7 is -40. So f of 7 is -40. And therefore f of b is -40. And so the question now is asking is -1 a number between -4 and -40? The answer is no. -1 is not between -4 and -40. So over here, we're just going to say no. Now, what I'm going to want you to do is this, is I'm going to give you problems that look just like this for the quiz and also on the worksheet. And what you're going to have to do is this. You're going to have to identify f of a and f of b and k. Okay, well, k will be given to you, but you're going to have to note, and then you're going to have to say whether k, yes or no, is between f of b and f of a, okay? All right, let's just do just one more example and see if you can do this one on your own. All right, so we're going to go a little crazy on this one. I just want to show you that your functions may not be polynomial, okay? So it's saying that let f of x equal sine of x. So we got this trigonometric function sine of x on the interval from a to b. And we're saying, is f of c equals k, is this a number that is between f of a and f of b, where a is pi over 3 and b is 3 pi over 2. Okay, now pi over 3 is smaller than 3 pi over 2. And our k that we're given is 1/2. Okay, and so here's what we want to know. Is the first thing we need to do is we need to identify f of a, then we need to identify f of b, and then we need to answer whether 1/2 is between f of a and f of b. Very simple. Why don't you go ahead and pause the video and try this yourself. All right, so f of a means, okay, since a is pi over 3, we're saying f of pi over 3, okay, which is sine of pi over 3, right? So we're plugging pi over 3 into the function. So sine of pi over 3, if you recall your unit circle, sine of pi over 3 is square root of 3 over 2, which, by the way, is really close to 0.8, okay, or like 0.83 or something like that, okay? F of b would be f of 3 pi over 2. And so if we plug 3 pi over 2 into sine of x, we have sine of 3 pi over 2, which is -1. Okay, and so we've identified f of a, we've identified f of b, and now we may need to, depending probably on the quiz that I give you on It's Learning, you're going to have to enter this as a decimal, chances are. And so let's go ahead and put in square root of 3 over 2 is 0.86. So we're going to put it in as 0.866, okay? And so now the question is 1/2, which, by the way, 1/2 is the same thing as 0.5, is 0.5 between 0.866 and -1? It sure is, and so we would put yes, okay? And so that's the basic idea. This is our first step. We're taking baby steps. This is our first step in being able to understand the intermediate value theorem.